Okay, everyone, so have this packet available, have a calculator ready, and let's take some notes. So when we come back from break, we're all ready to work through the next few modules, which have proportions as a method for problem solving. So just as a quick review, a ratio is just a fraction, or a ratio is a quotient of two numbers. A quotient, it's a fraction. It's a quotient of two numbers, or it's a fraction. A proportion is where a ratio equals a ratio, or a fraction equals a fraction. So for example, these are what is called a proportion because we have $4 for 3 notebooks is the same as $20 for 15 notebooks. So if you take a pause and you label $4 for 3, wouldn't it make sense that it would cost $20 if we bought 15 notebooks? So that is what is called a ratio. If we travel 60 miles in 1 hour, doesn't it make sense that we would go 180 miles in 3 hours? Yeah, so do you see we have a fraction equaling a fraction, a ratio equaling a ratio. So that is what is called a proportion. So to determine if two ratios are equal or to have a proportion, one method is what's called a cross product. And this is the only time we'll be using a cross product. And so to check to see if two fractions are equal to each other, you take the numerator of one and multiply it by the denominator of the other fraction. So a times d, and see if that equals the numerator and denominator for the other cross product, for the other product. So does A times D equal C times B? It's a very quick and easy way to see if two fractions are in a proportion. So is this a true proportion? Does 2 times 6 equal 4 times 3? Yeah, 12 equals 12. So yes, this is a true proportion. Now this one isn't quite as obvious. So does 4.1 times 5 equal 2.9 times 7? So 4.1 times 5 is 20.5. And 2.9 times 7, that's 20.3. So no, they're not equal. So this is not a proportion. The next type of problems that they're going to give you is they're going to say, okay, find the x value that will make this a true proportion. So you just want to think cross products. So 3 times 20, if this is a proportion, has to equal this product. So x times 5, or I'm going to go 5 times x. So 3 times, so we have this equation we're going to solve. 3 times 20 is 60. And then to get x by itself, to undo multiplication, we divide. So have your calculator handy. So 60 divided by 5 is 12. So to make this value, to make this equation a true proportion, x would have to equal 12. All right, let's try this one. So we're going to solve for w that will make this a true proportion. So let's do our cross product. So 2.4 times w equals 3 times 3.6. All right, let's have that calculator handy. So let's do 3 times 3.6. That gives us 10.8. So to get W by itself, we're going to divide. Remember I said division is like usually the last thing you always want to do to get these unknowns by themselves. What you do to one side of the equal sign, you have to do to the other. So 10.8 divided by 2.4 looks like W has to equal 4.5. All right, so let's practice. So what I recommend that you do is pause the video and just solve for the unknown to make these 4 boxes a true proportion. And if you have to round, they said round to the nearest hundredth of a decimal, and that would be 2 decimal places. So pause the video and then solve for the unknown that will make these true proportions. All right, so let's go ahead and check. Hopefully you paused the video. So this would be 18 times 100, and then this product would be 20 times x, or x times 20. So 18 times 100 is 1,800 equals 20 times x, and then to get x by itself, we're going to divide both sides by 20. So hopefully you guys got x equals 90. That's the value that will make this a true proportion. Okay, for this one, we'll have 2 times n equals 8 times 7. So 2 times n equals 56. And to solve for n, we're going to divide both sides by 2. So 56 divided by 2 is 28. So n has to equal 28. Okay, for this one, start with our cross product. So 4 times 5 equals 14 times x. So 20 equals 14 times x. And to get x by itself, since it's multiplication connecting them, we'll undo that multiplication by dividing. Okay, so you can put these in as a fraction. I'm going to go ahead and round this to 2 decimal places because that's what the directions said to do, to round to the nearest hundredth. The 2 is in the hundredth spot, so the 8 dictates it to go up to 0.43. Right, and the last one, we'll do this cross product. So x times 9, or I like to write the coefficient first, equals 4 times 15. Okay, 4 times 15 is 60. So 9x equals 60. And to solve for x, we'll divide both sides by 9 to get the x by itself. Looks like I got 6.67. Okay, the other type of problems that they're going to give you are some word problems. And they're going to have a spot or a space on the test or on the final where you have to show the proportion used to solve for your unknown. So this says Fly-Right Airlines reported on-time arrivals for 78 out of 100 flights. Predict the number, all right, here's what we're looking for, of on-time arrivals if we have 650 total flights. So for this problem, we're looking for the number of on-time arrivals. Now, they'll always give you one of the fractions in the problem. So in this case, they said we have 78 on-time arrivals out of 100 flights. So I like to label. And then I'll be consistent when I set up my other fraction. So the numerator, the 78 means on time. The denominator, which is 100, is the total flights. So I'm going to do the same thing over here. So we're looking for the number of on time. So since it's in the numerator in this fraction, we need the number of on time in the numerator of the other fraction. But that's what we're looking for. That's what we're going to call x. And the total on-time arrivals out of 650 flights total. So this is on time out of a total of 650 flights. So this is where we do our cross product. So 78 times 650 equals x times 100, or 100 times x. So let's pull out our calculator. So this side will be 50,700. This side is 100 times x, and to get x by itself, we're going to divide. So it looks like x will be 507 on-time flights out of the 650. All right, let's try a couple more. So in designing a new hotel room, or a new hotel that has 750 rooms, planners want, okay, here it is, 3 out of 5 rooms to be non-smoking. Okay, so we want 3 non-smoking rooms out of every 5 rooms. So let's label. The 3 have to be non-smoking out of a total of 5. So they want us to calculate the number of rooms that should be non-smoking. So x is going to be non-smoking rooms. And the total number of rooms is the number of rooms in the new hotel. So the total is 750, and we want to know how many we should designate to be non-smoking if we want for every 5 rooms, 3 to be non-smoking. So there's our proportion, and we'll go ahead and do the cross product. So 3 times 750 equals this product, 5 times x. Okay, get your calculator out. So 3 times 750 is 2,250. And to solve for x, right, we want to divide to undo multiplication. So if you do that on your calculator, it looks like they're going to want 450 rooms out of the new hotel to be non-smoking. Now sometimes it's easier to draw a picture, and I think with the shadow problems that's definitely the case. So I'm going to draw this problem out where they talk about a tree and then the tree shadow. And then they talk about a little girl. I'm sure you love my drawings. So here's the girl. This is her height, and this is her shadow. Now, there's lots of ways you can set up these proportions, and I think this is a good example to show you why that's the case. So it says a tree casts a shadow that's 10 feet long, and Matilda is standing next to the tree. It says her height is 5 feet, and her shadow is 2 feet. So they said, how tall is the tree? So let's let that be X. X is the height of the tree. So there's a bunch of ways that you can set this up. You can you could talk about the height of the girl and to the shadow. So if you wanted to go, the height of the girl is 5 and her shadow is 2. Let me label this. Shadow and height. So if you set it up that way, then you automatically have to do height on this side for the tree. And over here you have to do shadow. So X for the height and 10 for the shadow. That's one way you could do it. Sometimes people will think of it the other way. And you don't have to write this down, but some people will go maybe, let's see, the shadow of the girl and the shadow of the tree. So this is girl shadow, and this is tree shadow. So then over here, we would do the height of the girl, because we're talking about girls on the top. And then over here, it would be the height of the tree, and that would be on the bottom. Well, that looks so different, but if you look at the cross products, it's going to, as long as you're consistent, girl is to tree, and then girl is to tree. Do you see? Girl shadow, tree shadow, girl height, tree height. Even though we set them up differently, do you see the cross products are going to be the same? 5 times 10 equals 2x, or 2x equals 5 times 10. So there's lots of different ways you can set these up as long as you're consistent. So let's solve this. So 2 times x equals 5 times 10. 5 times 10 is 50. And then to undo multiplication, we divide. So it looks like x is 25 feet. So the height of the tree is 25 feet. So there's more ways than one you can set these proportions up. And as long as you're consistent, it won't be wrong. So why don't you just pause the video and try maybe do these 2 word problems and just be consistent with how you set up your proportion, and then turn on the video and check to see how you did. Okay, so I'm going to start working through it. It says an employee earns 6 days of paid vacation after working for 21 weeks. How many days of paid vacation? Okay, so that's my X. Number of days of paid vacation. So how many days of paid vacation will they earn if they work for 49 weeks? Okay, so I'm going to take this first sentence and make it into my fraction. So 6 days for 21 weeks. These are your vacation days, and these are the weeks of work. So over here, I'd have to put days on the top and weeks that you worked on the bottom. So it looks like we're looking for the number of days of paid vacation, right? So this is my days. and then 49 weeks, weeks was in the denominator, right? So that's my weeks. See how we're just consistent? So let's do our cross product. 6 times 49 equals x times 21, or 21 times x. However you'd rather see it. And we'll go ahead and do our calculator work. So 6 times 49 is 294 on the left-hand side, 21x on the right-hand side. So to get x by itself, we're going to divide by 21. So it looks like the person's going to get 14 days of vacation. All right, and 2 more. All right, so it says 4 limes sells for 76 cents. All right, that looks like it's going to be my first fraction. This is limes, and this is cost. So they want to know how much will 6 limes cost. So I'm looking for the cost. That's going to be my x value. So we have to be consistent. I'm going to put limes on the top and cost on the bottom. So we're trying to find out how much 6 limes is going to cost. And we just do our cross product. So 4 times x equals 6 times 76 cents. And then we have the skills now to solve this. So we have 6 times 76 is $4.56. And then we're going to divide by 4, right? We always divide as our last operation. And it looks like x is going to equal, put the dollar sign there, $1.14 for the 6 limes. It's just all done with a proportion. Setting up so one fraction equals the other, and then just taking a cross product. All right, last one before we get into some currency questions. It says a bag of fertilizer covers 2,400 square feet of lawn. How many bags of fertilizer are needed to cover a town square? Oh, that's 55 feet. Oh, maybe it should be 300, but it doesn't matter. Let's just label 300 feet by 55 feet. I think we're going to need area for this one. So we need to figure out how many square feet are going to be in this lawn. So how many square feet will 55 feet by 300 feet cover? Okay, well, 55 times 300 is 16,500. And feet times feet is square feet. So this is how big the lawn is. And for one bag, it covers 2,400 square feet. So let's go ahead and set up a proportion. So one bag covers 2,400 square feet. So how many bags will cover 16,500 square feet? Put the square feet in here, just to show you that we're consistent. And one bag, and then this is X bags. So we just cross multiply. So 1 times 16,500 equals x times 2,400. Okay. So division is always last. And then we need to talk about rounding. So pull out your calculator and figure out how many bags we owe. Now, we wouldn't be able to walk into the Home Depot and go, hey, can you give me 6.875 bags of fertilizer? They'd say no. So that's why it says round up to the nearest whole bag, because we would have to tell them 7 bags. Right? If we only choose 6 bags, it won't be enough. So we'll have a little bit of fertilizer left over. We'll have enough to cover the lawn. All right, and then the last little bit are setting up proportions for conversion factors with money. This is the last thing. So anytime they have these on the final, they have a separate spot. Like I must have cut it off that says show your proportion here. So we're going to get in really good habits to show our proportion when solving these. So it says one night at Great Wolf Lodge Water Park in Niagara Falls cost 375 Canadian dollars. So here they gave us the most updated currency exchange. So they want us to be able to figure out how much will it really cost in US dollars with this current exchange. So do you see how they gave us a fraction? 3, I'll put Canadian dollars, is equal to 2.37 US dollars. So we're trying to find how much in US dollars will the hotel room cost if it's 375 Canadian dollars. Okay, so let's take our cross product. So 2.37 times, that's CD right there, Canadian dollars. 375 equals 3 times X. Let's pull out our calculator. So 2.37 times 375 and then to get X by itself, we divide by 3. So it looks like it's going to cost $296.25 in US money, because Canadian currency is different than the US currency. So if the hotel says you owe us $375, we're really only going to be paying them $296.25 in US dollars. All right, let's try one more. Actually, there's 2. A tourist traveling from Brazil to the United States exchanges 700 Brazilian reals for $246.40 in US dollars. How much US dollars would a tourist receive for 1,000 Brazilian reals? Okay, so they gave us the first fraction in our proportion. For 700 Brazilian reals, we get $246.40. So I'll put this is Brazil and this is the US. So we're looking for how much money in US dollars would someone receive if they gave them 1,000 Brazilian reals. So you see I have from Brazil on the top US on the bottom. From Brazil, see, the Brazilian reals on the top, and then unknown amount of money in US dollars on the bottom. Oh, let's cross multiply. So 700 times X equals $246.40 times 1,000. Okay. And then division is always last. So it looks like you'll get 352 US dollars for 1,000 Brazilian, what their currency is called in Brazilian reals. So 1,000 of the Brazilian dollars is 352 US dollars. All right, last one. It says if we plan a trip to Spain and bring $500 in cash, how many euros are we going to get up? How many euros are we going to be given to spend up in Europe, up in Spain? All right, well, here's our first fraction. We have 0.77 euros for every 1 American dollar. So if we give the bank 500 US dollars, how many euros are we going to get? All right, so here we go. Let's cross multiply. So 385 equals 1 times x. And if you need to divide by that 1, that's perfectly lovely. It's not going to change anything. So it looks like we're going to get 385 of something. So we gave the bank $500 in cash, in US money, and they gave us 385, so we have to label it correctly. This is going to be in euros. So you can put that symbol in the front or the back, but in Europe they usually put it in the front. All right.